Then, now let us move on to the next ones. So let me again write Kf equal to K Q1 Q2 divided by D square. Let us talk about the constant K. Constant K is called as electrostatic constant. Electrostatic constant whose value is equal to 1 by 4 pi epsilon r epsilon naught into epsilon r. The value of 1 by 4 pi epsilon naught is equal to 9 into 10 to the power of 9, while the value of epsilon r, it is just a number. It is just a number, and this number can vary, will vary for every material. For example, the value of epsilon r for water is equal to 80. The value of epsilon. What is this called? This is called as relative permittivity. Relative permittivity. Let us not come back to it as, the value of epsilon r for vacuum is equal to 1. Okay. While the value of epsilon r for a metal is equal to infinity. Okay. So now let us understand based on these values what does it mean. Now first let us take two equal charges plus q and plus q. Separated this by 1 meter. I have kept this in air or vacuum, and I am asking you what is the force between them. The force between them is nothing but 1 by 4 pi epsilon naught. Okay, let me work it out here. So I will say the force between two charges Fa is equal to 1 by 4 pi epsilon naught into the value of epsilon r for air is 1 into q square divided by, I kept it at 1 meter, this 1. So answer should now be equal to q square into 9 into 10 to the power of 9, because 1 by 4 pi epsilon naught is 9 into 10 power 9. So this should be 9 into 10 power 9 into q square. This should be your value for the force between two charges when it is kept in air. Now when I keep this in water, what can happen? When I keep this in water, I'm going to use all of them same. I'm not going to change anything. So when I'm going to do this for water, I'm going to substitute this 1 by 80. Right? Because for air it was 1 here. For water, only this will change. The rest of them remains a constant. So this will now be equal to 1 by 4 pi. 1 by 4 pi epsilon naught into 1 by 80 into q square. This will now be equal to F air divided by 80. Can I write like this? F air divided by 80?
Yes, sir.
So which means the force between any two charges when kept in water at the same distance will now reduce to 1/80th times the force between the two charges in air. Right? The force is now really reducing here. Correct?
Yes, sir.
Okay. Now let us consider what happens in metal. Now when I take the same two charges, take a metallic plate, and when I keep these two over here, the two charges, then I observe the force in metal will now be equal to F air divided by infinity, because the value of epsilon r I'm going to take over here. Thus this becomes infinity or this becomes 0. Correct?
Yes, sir.
So in other words, we say that here there is a resistance to the electric field between the two charges in water, while the electric field is more permitted in case of air, and in case of metal, the electric field on the surface is literally 0. Or there is no force between any two charges in a metal, on the surface of a metal. Correct?
Yes, sir.
On the surface of a metal, there is no force between any two charges. The reason is because a metal does not resist the charges. It allows its free motion of it. As a result of it, two charges will not oppose each other, and they will be free to move across. That's the term permittivity. So we have been looking at a term known as permittivity here. Permittivity. So when we talk about permittivity, when the permittivity value was 1 for air, then you see there is a very larger force. But when we go to water, when we go to metal and so on, the permittivity value is larger and the force between the two charges is lesser. In other words, this tells us the electric field can easily pass in a material. An electric field can easily pass in a material. Okay, and this is what is the factor that defines it. Larger the value, more number of electric field lines can pass through it. Lesser the value, less number of electric field lines can pass through it. Is this clear?
Yes, sir.
And now, in other words, we are now defining, or we are now talking about, hey, I have two charges, I have an electric field. How much electric lines of forces can percolate through a medium? Is it that if the source gives you 100 electric field lines, will all the 100 electric field lines will be able to pass through a medium? Or is it that they are going to get restricted? If I'm going to ask this question, so definitely, then it depends upon the medium that you are talking about. If your medium is metal, then the source, if it gives you 1000 lines, all the 1000 lines are made to pass through it. But if it is water, it's not going to pass all 1000 lines. Maybe only 80 lines are being permitted to get inside it. And if it is air, very few lines can pass through it. Right? Is this clear?
Yes, sir.
Okay. So now, let us consider a socket. Let me come back to a socket. We have a socket. Now let us say this is charged. Okay, the charge has come over here from the electric field, and this is being completely charged over here. Now, when I stand on the ground, I'm negatively charged. Okay, so as a result of it, when I keep my finger very nearby to the socket, okay, which is carrying a current of around 2 amperes, okay, I will not get charged, or the charges will not be in a position to jump across. The reason is because there is air in between them. I don't feel any force between the negative charge and the positive charge. And secondly, air is an insulator, so it does not allow the jumping of the charges. Is this clear?
Yes, sir.
Right. So permittivity is a very important factor in electrostatics. So to determine what is the force between any two charges. Okay. Now, so we have seen what is the value of permittivity. I didn't tell you. Okay, let me again continue with permittivity. 1 by 4 pi epsilon naught. The value of 1 by 4 pi epsilon naught together, we need to remember this, 9 into 10 power 9. The value of epsilon naught alone is given by 8.85 into 10 to the power of minus 7. Okay, so these are some of the values that we need to remember over here. Okay, so what is the unit of permittivity? Okay, wait. Before that, I would like to say this is your permittivity of free space. Usually what we do is we write epsilon is equal to epsilon naught into epsilon naught. When we talk about the permittivity of a medium, so this is the thing which we discussed totally over here. Okay. Now, what is the, what was I asking? I was asking you what is the unit here? What is the unit of K and what is the unit of epsilon naught? Okay, let us do that one. So can you tell me what is the unit of K?
So K will be, so we can just do dimensional analysis. So F is mLT power minus 2.
Exactly. Yeah, it should be Newton meter square per Coulomb square.
Yes.
Okay, I asked about units and not about the dimensions. So this should be Newton meter square per Coulomb square. Okay, then what is the unit of epsilon? Epsilon naught.
It's just the inverse, right? So it will be
Exactly. So this should be
per Newton.
Coulomb square per Newton per meter square. Sometimes this epsilon r is also called as dielectric constant. Dielectric constant represented by the letter K. Okay, this you will be studying this in the chapter on capacitors. Dielectric constant K. And dielectric constant K will be a number which I already told you. It depends upon the material. And then when you talk about dielectric is nothing but an insulator. The other name for dielectric is nothing but insulator.